let's continue our conversation about volume. But now let's move on to cylinders and cones. As a recap, when we look at volume equations, the large B stands for the area of the base. So when we move down here to talk about cylinders, cylinders have a base that is a circle. So we need to know what the area of a circle is. An area of a circle is pi r squared, and we'll continue our volume conversation by multiplying it by the height. So here in our first example, here is my circle. So my base is pi r squared, and I'm going to leave it with pi in the answer. So my base is 9 pi, and I'm going to call it units squared since we weren't given a specific unit of measurement. So my volume is going to take that 9 pi and multiply it by 7 because the height of my figure, my height of my cylinder, is 7 units. So this is going to give me 63 pi units cubed. You need to be comfortable with the decimal answer, but I'm only going to worry about pi. Be comfortable with finding what 63 times pi is for the decimal answer, but know this is what I'm going to take 9 times out of 10. Another example, again, the big B stands for the area of the base, and we know that my base is a circle when I have a cylinder. So this is going to become pi 8 squared. So we're going to call this 64 pi units squared for area. And to find the volume, we're going to bump this circle out a unit of 3 to create a cylinder. So we need to find out what 64 times 3 is. We get 192 pi units cubed. Cones down here at the bottom. Cones also have a base of a circle, but we're still following this formula up here. We're putting in an addition of 1/3. 1/3 my base times my height. So again, my base is a circle. So I have an area of pi r squared. So this is 25 pi, and I'll squeeze in units squared. Volume, I need that 1/3. I need the area of my base, 25 pi. And my cone is being pushed out how many units? Well, it's not being pushed out 13 units. This is called a slant height. So what fun little formula am I going to have to use to find the height of my cone? Hopefully you know it's the Pythagorean theorem, and this is a Pythagorean triple, so my height is 12. So in my calculator, I'm going to multiply 25 times 12, and I'm going to divide that by 3, and I get 100, and I'm still going to leave pi in my answer, and this is units cubed. Another example, again, a cone has a base of a circle, so I need to find the area of my base, but I'm missing my radius. So once again, we're going to have to use this Pythagorean theorem, and I find that this is 8 when I do that. So the area of my base, I'm just going to write in 64 pi units squared. My volume, I have 1/3 times my base, 64 pi, times my height. How am I extending this cone? Upward, 15 units. So in my calculator, I have 64 times 15. I'm going to divide that by 3 and get 320 pi units cubed. You do have a few more pages in your packet that practice this concept, but I also want to introduce to you spheres and composite figures. So let's flip these notes over onto the back. Here is the volume of a sphere. And so we are following the area of a circle formula. However, my circle is being pushed out to find volume. That's why my R is cubed. So we will just substitute this into our formula as we see it. So 4/3 pi, and my radius is 7 cubed. So if you put this in your calculator, you're going to find that you get a decimal, and they want us to round to 2 decimal places. And so that would be 0.33. So 457.33. We cannot forget about the pi, and my units are inches cubed. In problem number 9, we're given a diameter. So I need to be able to find my radius. So I'm going to take 2.5 and divide it by 1.25. Excuse me. I'm going to take 2.5 and divide it by 2 to find that I have 1.25 as my radius. So then I go back to my sphere formula. And I'll put this into my calculator. And I'm going to round it again to 2 decimal places. So 2.60. And we cannot forget about the pi and my units cubed. I want you to think about number 10 on your own, and we'll have an in-class discussion about it. So for number 10, what if you did triple 21 and got a radius of, what if I tripled the 7 to get a radius of 21? Okay, or what if I triple 1.25? How is that going to change my overall volume and what relationship is built? Now, composite figures are just an addition of 2 solids on top of each other. So in 11, we notice that there are 2 figures. There's a prism and there's a pyramid. So we're going to add these 2 things together. We're going to add the volume of the pyramid to the volume of the prism. So we know that the volume of a pyramid is 1/3 base times height. And we know the volume of a prism is just base times height. This is also located on your formula sheet in case you have not quite memorized them yet. Well, if I look at my pyramid, my base is a rectangle. And it has a width of 5 and a length of 6. So this is going to be 6 times 5. And my height, I'm bumping this up a unit of 7. And I'll keep that 1/3. So when I place this into my calculator, this becomes 70. So now let's look at my prism. This is a rectangular prism, and very similar to my pyramid, I'm going to have the same area of my base, but now my prism is being bumped out a unit of 3. And so here my volume becomes 90, and the volume of both of my figures together is 160, and we cannot forget about our feet cubed. Now let's look at the figure below. We have something going on here. We have a cylinder, and we have what appears to be a sphere, but does my sphere open up all the way? Is it full? It's not. So if I have half a sphere, that is called a hemisphere. Okay? So we are still going to add the volume of our cylinder plus, and we're going to do the volume of a hemisphere, a hemi. Okay? The volume of my cylinder is base times height. It's the same as a prism. But I know that the base of my cylinder is a circle. So now I'm going to be finding pi r squared. And my cylinder is being bumped out a height of 7. So we should get 63 pi for this volume. Now, we've talked about the volume of a sphere, so we know that's 4/3 pi r cubed. But if I want a hemisphere, I'm going to need to take half of this answer. Okay, so I'm going to take half, and I know this is going to be 4/3 pi, and my radius is 3. So this is going to become 36 pi. And so if I need half of that, that's going to be 18 pi. We'll drop our 63 so we can see what we're adding. So the volume of this composite figure is going to be 81 pi miles cubed. And I apologize. Let's look at the notes down here at the bottom. As a recap, I substituted in my radius. I found the volume of my sphere, and then I took half of it. The composite is adding these two together to get 81 pi miles cubed. This concludes the rest of your packet. You now have all the notes and information that you need to be successful on the rest of your test. Happy practicing!